Okay, Mr. Gilboy's class. This is Mr. Renard. I'm going to be the voice on the screen, at least for today. And we'll see where everything goes from there. So, what we're going to be doing is we're going to be reviewing 2.6. That's the section you guys just went over. I know that you were given a quiz on 2.4, 2.5, and 2.6. You guys did pretty well on 2.4 and 2.5. And not so well on 2.6. So basically, I'm going to pretend that you guys never did 2.6. So for those of you who got it, this is going to be just viewed as a review. But for those who didn't, it's a chance to get reintroduced to the material, and we'll go from there. So, those are my cats, Cleo and Rarity, apparently having a disagreement about something. Anyway, back to the math. So, 2.6, the title is Proving Angles Congruent. So the first thing I want you guys to do is get out your notes. You guys should all be using the C notes, the focus note taking. And I want you to put that down as your, in the subject area. And then for the essential question, you're going to put down, how do I prove angles congruent? It's pretty straightforward. So, hit pause, wait for everyone to get done with that, and then hit play. So the first thing we need to do is make sure that we're all dealing with the same vocabulary. So what I want you guys to do first thing is copy all of that down into your notes. A theorem is a statement which can be proven true. Okay? So it's not something that we take as true. It's not something we assume to be true. It's something which can be proven true. So you should have gone over postulates already. Postulates are things which we assume to be true. They're statements which just seem so fundamentally true that we take them as true. A theorem we can prove to be true. So we're going to start off with the vertical angle theorem. And the vertical angle theorem says that vertical angles are congruent. That's what that little squiggly line on top of the equal sign means. Remember, congruent means the shapes are the same. Equal means the measurements are the same. So if two angles are congruent, that means they are exactly the same. They're like carbon copies of each other. And it means that their measures are equal. Okay? Oh, I thought I had paused, so apparently I was just sitting here recording for the past 10 seconds while I picked something out of my teeth. So that's cool. Anyway, so when we do a proof, this is a 2-column proof. We have statements and reasons. I think later on I use steps and reasons, kind of the same thing. But on the left-hand side of this column, you're going to have your statements. These are what we're doing. Think about it like when you show your work, this is how you show your work. On the right-hand side, the reasons, we're not just doing the work, but we're actually sitting there and saying, hey, listen, this is the specific rule, this is the specific law, this is the specific postulate, this is the specific theorem that I'm using to justify my steps. Okay? So, this is what I want you guys to do. I want you to put your pencils down. I want you to make sure all your phones are away, earbuds out, earphones out. I want you just to watch the process of working through this proof. And then, after we've gone through it, you'll have a chance to copy it down. But I really do want your attention right now on the how a proof is built and what it looks like. So, statements. We almost always, 99.9% of the time, when we're doing a proof, we're going to start off with a given. So here we're given that 2 and 4 are vertical angles. So we say 2 and 4 are vertical angles. How do we know that? Because it is given. Okay? So we're saying that 2 and 4 are vertical. How do we know that? Because it's given. So then what we want to do, and again, this is going to be some jumping back and forth, so I apologize, and this also will hopefully not be confusing, because by the time you write it down, everything will be up. But we're going to say that 1 and 2 are supplementary, and that 1 and 4 are supplementary. So when we look back here, so we're saying that 1 and 2 are supplementary, and we're saying that 1 and 4 are supplementary because they are a linear pair, both of them. So then when we jump forward here, we know that angles that form linear pairs are supplementary. You can also just call it the definition of linear pairs. But here we know that because the definition of vertical pairs is that they are created by opposite rays. We know opposite rays form linear pairs. That therefore, we know that 1 and 4 and 1 and 2 are supplementary. Well, what does that mean? What does supplementary mean? Well, supplementary means that they add up to 180 degrees. So we're going to say that because we know they're supplementary, we know that the measure of 1 plus the measure of 2 equals 180. And the measure of 1 plus the measure of 4 equals 180. And the reason for that, why we know that, is that's the definition of supplementary angles. So that's a really common kind of pattern you'll see in proofs, is you'll write a word down like supplementary or vertical or congruent or something like that. And then the next thing, you're going to use the definition of that word you just used to further explain the relationship between whatever it is you're doing. So here, first we identify 1 and 4, 1 and 2 as supplementary. And then we're like, okay, now that we've identified them as supplementary, what does that mean? Well, it means that the measure of their angles opens up to 180 degrees. So, now, here's another common thing you're going to see a lot of in proofs. If you look at these proofs, you see, or if you look at this example, you see how you have two things which add up to 180 degrees. Well, if they both add up to 180 degrees, that means they have to be equal to each other. And when we do that, that is called the transitive property of equality. If two things are equal to the same third thing, then they're equal to each other. Think about it this way. I know that 4 times 3 is 12. And I know that 10 plus 2 is 12. So because I know that independently 4 times 3 equals 12 and 10 plus 2 equals 12, because they both equal 12, I could also use the transitive property and say that 4 times 3 equals 10 plus 2. That's the transitive property. So here we had 1 plus 2 equals 180, and 1 plus 4 equals 180. And that then gives us 1 plus 2 equals 1 plus 4. Now notice how we have the measure of angle 1 on both sides. So what I'm going to do is I'm going to subtract it. I'm going to subtract the measure of angle 1 from both sides. And this gives me the measure of angle 2 equals the measure of angle 4. What allowed us to do that was the subtraction property of equality. Subtraction property of equality states that if you subtract the same amount from both sides of an equal sign, then you get to keep the equal sign. Now finally, number 6 is going to be our last one. And we're going to say that 2 is congruent to 4. The reason being that we already said that their measures were equal. And if their measures are equal, then, whoa, that got ugly. If their measures are equal, then they're congruent. And so that is the definition, DEF period, of congruent, and I use the equal sign with a squiggly line on top, angles. And the angle sign with an S in front of it is a valid way to write angles. Even your book does it. So, when I teach, I like to do a process that I learned about at the beginning of the year. It's called 10-2-2. I don't know if Mr. Gilboy does that, but that is basically for every about 10 minutes of notes, you are now going to be asked to spend 2 minutes rereading your notes. Okay, so you're going to spend the next 2 minutes rereading your notes, and you're going to write a summary of it. The following 2 minutes, you're going to be discussing it with someone sitting next to you. I don't know what, I call them study buddies. I have, elbow partners, whatever the case may be. But so 2 minutes of complete silence, looking over your notes, writing any summaries, writing any questions you may have about your notes, because remember, your notes are a note to yourself in the future. So it doesn't matter whether or not I understand them, or your sub understands them, or whoever understands them, or Mr. Gilboy understands them. What makes sense, what's important, is that you understand them. Because I know that a lot of times, especially in geometry, you're sitting there and you're taking notes, and you got all these shapes and arrows and things like that down on your paper, and you look at it when you're taking notes. I'm like, wow, those are a lot of good notes. But then, when you actually need to use them, you go back and you're like, what was I thinking? I don't even know why I wrote this triangle and these numbers here. So that summary is a chance for you to go back and kind of remind yourself what these notes are about. So we've done 10. So whoever is running the class, please time out 2 minutes. That's them working by themselves, and then 2 minutes of them conversing, seeing if they can answer each other's questions. Normally, when we come out of the 10-2 cycle, I could then go and give them a chance to answer or ask any questions that they have remain unanswered. So hit pause, leave this up, and when you are ready again, hit play. So, it has been a long 4 minutes for you. For me, it has been all of about 8 seconds. So, once a theorem is proven, we get to use it, okay? So, we just proved our vertical angles theorem, so now we're going to use it. Here we have 5x and 4x plus 40. Those are vertical angles. They got the little bow tie thing going on. See, right there, bow tie. Cool. So, because they're vertical angles, we know they're congruent. Because they're congruent, we know their measures are equal. So we can just set those two numbers equal to each other. So we have 5x equals 4x plus 40. So what we're going to do is we're going to subtract 4x from both sides. That's the good old subtraction property of equality. This leaves us with x equals 40. Now, if the problem asks for the to find x, this is where you'd stop. If it asks to find the measure of the angles, well, then what we do is we take this 40 and we plug it in there and down below to make sure that basically checking our work. But so if it asks just for x, then we're done. If it asks for the measure of the angle, you go back and you plug x back in. See how it goes. So this right here is the proof using the vertical angles theorem. So once we have proven something, we can then use that theorem to prove other theorems. Okay, so once we prove the vertical angle theorem, we can look at other things which require the vertical angle theorem to make them work. So I want you to quickly copy down problem 2. Make sure that you have both the statements and the reasons. Teacher, just hit pause, wait until everyone's done, and then move on. Oh, okay. So here I'm just showing you that we have to use the vertical angles theorem. See how vertical angles are congruent? That is the vertical angles theorem. So the reason you don't have to put down the actual theorem. They could have just they could have put vertical angles theorem down as the justification for that step. Okay, another definition. Copy that down. So this says congruent supplements theorem. If two angles are supplementary to the same angle, then they are equal to each other. Remember, supplementary means that they add up to 180 degrees. So if I know that angle A plus angle B equals 180, and angle B plus 180 equals, or plus 180 plus angle A, B, so if A plus B equals 180, and B plus C equals 180, then I know that A and C have to be the same amount. So once everyone's done, move on. So what we're going to do is we're going to quick do a proof on this one. Again, I want you to put your pen and pencils down. I want you to watch me walk through it, and then I'm going to give you guys one to do. Isn't that exciting? I know. So, given 1 and 2 are supplementary, 1 and 3 are supplementary, prove that 2 is congruent to 3. So again, this is a proof of our theorem. Our theorem says, hey, is this true or not? And here we are, we're proving it. So, we got our steps and we got our reasons. So, step 1, we're going to write down our givens. Always a good place to start. Now, you guys were just with us, so you know what supplementary means. Right? So we're going to go 1 plus 2 equals 180. And 1 plus 3 equals 180. And again, here's the pattern. We say something's supplementary, and then the next step is we kind of define that mathematically. Okay. Oop, went too far. Okay. So, definition of supplementary angles. Again, we have that same pattern. We have two things. We have two quantities which are equal to 180 degrees. Since both are equal to 180 degrees, we can set them equal to each other. So now we got to cut out that 180. So we have 1 plus 2 equals 1 plus 3. Again, that process is called the transitive property of equality. We're then going to subtract the measure of angle 1 from both sides, and that gives us 2 and 3 being equal. And we're almost there. Subtraction property of equality. And then number 5, we're going to go 2 is congruent to 3, because the definition of congruent angles is that angles with equal measures are congruent. So so there's that. And that is the proof of the new theorem we just did, but using what we already have. I'm not sure if that made a lot of sense. I kind of lost my train of thought halfway through it. So just like we have the congruent supplements theorem, we have the congruent complements theorem. So write that down. And I want you guys to take another 2 and 2 break before moving on. So now you're back. You're brains are all fetched, you're ready to go. So given one, here, I'll just go here. So this is, we were going to try and prove the complementary or congruent complements theorem. So the congruent complements theorem says that if two angles are congruent to, complementary to the same third angle, then they're congruent to each other. So once all of this is copied down, I want you guys to take about 4 or 5 minutes to go through this. And again, it's late. I don't know if you guys can see the time on this, but it's well after midnight. So I'm sorry if my train of thought isn't always as precise as normal. So what you're going to do is you're going to copy this down and then work to try and complete the reasons for each of the steps. So teachers allow them time, and then we can move forward. So, number 1, given. Number 2, again, there's that pattern. We said these two angles are complementary. Well, what does that mean? It means that they add up to 90. So, definition of complementary. What, Cleo? My cat's angry at me that I'm not asleep right now. Or she wants to go outside, but neither one of those is happening. So, anyway. So, number 3. 1 plus 2 equals 1 plus 3. That's a 1 right there. And the reason we can do that is the transitive property. Our dear friend, the transitive property. I don't know what we do without him mathematically. So now we've got 1 plus 2 equals 1 plus 3. We're going to subtract 1 from both sides. That's the subtraction property of equality. That's what allows us to do it. That's why we have these proofs. Not only can we just sit there and go, hey, listen, I found some new theory. It needs to be mathematically proven. It needs to be walked through. And so we need to justify each and every step, even if it's something like 1 plus 1 is 2. Okay, well, we need to be able to justify why does it equal 2? Why are we allowed to do that? Things of that sort. So that leaves us with number 5, which is the definition of congruent angles. And again, what the definition of congruent angles is that angles that have the same shape and same measurement. So we know that 2 and 3 have the same measurement, and therefore 2 and 3 are congruent. Here are 2 more theorems. I like to make up, so it says Theorem 2.4 and Theorem 2.5, which is great, except Theorem 2.4 simply just means it is the 4th theorem in this chapter. Same thing with Theorem 2.5, it's the 5th theorem in this chapter. So I like to make up names for them, which make sense outside of the book, because, yeah. That way, if you talk about them and know what they're, have a general idea of how they're worked, then you have that knowledge to be able to present at any time you get challenged with it. Not that anyone's going to be doing a lot of challenging of your geometry skills, but anyway, write those down, and then I want you guys to try and find the values of x and y. Give them, let's say, 2 minutes working by yourself, and then 2 minutes with a friend or study buddy, and we'll see where we're at. So, Now that we're back, what we're going to do is we're going to write down what we know. We know that 2x plus y equals 180 because they're a linear pair. We know that y plus 76 equals 180 because they're a linear pair. We also now know that 2y has to equal, or 2x has to equal 76 because they are vertical angles. So I'm going to take that bottom one first. I'm going to just divide both sides by 2, and I get x equals 38. I can then take that 38 away with me and plug it back in. 2x plus y equals 180. We're going to plug that 38 in. Oh, I'm sorry. Got a little bit ahead of myself. So we also have y plus 76 equals 180. Now here's the thing. You can plug x into either one of those and you're going to get the same answer. It really just matters on which one's easier for whoever. But yeah, it doesn't matter. They're both going to get the same answers. So we're going to plug our x in, or we're going to solve for y. So we have y equals 104. That's just this equation right here. And then over on the other one, we're actually going to take that x equals 38, plug that in, and we're back to kind of where we started. Notice that now we have 76 plus y equals 180, which is the same equation as that. And so once we get to 76 plus y equals 180 and y plus 76 equals 180, that's the same thing. So we know that we're going to get the same y. Okay, so sometimes they don't just ask you to find x, but they actually ask you to find the value of the angles too. So it's the same general idea. Here we have two vertical angles, so we're going to set them equal to each other, x plus 90 and 4x. We're going to subtract x from both sides, and we get 3x equals 90. Divide both sides by 3, and we get x equals 30. Now, a lot of places stop right there. We're going to take it an extra step and say if they're not where they're supposed to be, where are they? I have no clue what that just... So what we're going to do is we're going to take that 30, and we're going to plug it back in to get not just the x, but the value of the angles themselves. So we go 4 times 30 and get 120. If we did it right, we should be able to plug the 30 in over there and get the exact same answer. This should basically be it for the class, but if not, then there will be a worksheet being passed out, and get going on that. And have any questions, feel free to ask any of the math teachers. And thank you guys for putting up with this and dealing with this. And I know it's new and different, but I really appreciate all your guys' help in making the best of the situation. Thanks. Good night.